Today, let's see what bias and variance is. Right? You would have come across this term when you would have done modeling, right? So either you would have trained any classification or uh, regression models, right? Any ML model has two different problems, right? Bias and variance, and uh, just you train the model, you get the predictions out of the model. Now based on the predictions, right, you perform error analysis and you figure out your model can suffer from either one of these two issues, right? And the art of machine learning lies in balancing these two problems, right? So if you have high bias, then obviously you'll have low variance, and if you have high variance, you'll have low bias. And there is a sweet spot. If you could figure out that by balancing both these, then you would likely to have an optimal model for your prediction. Now let's see what bias is. The image uh, you see on the slide, right? So it's nothing but, you can imagine, right? So this is an unexplored area, right? But still you see this mud patch on top of this unexplored area, right? So you all know the reason behind this, right? So either uh, humans have been using this area or some cattle have been using it, right? So if you keep exploring a certain patch of area, then you get something like this, right? Yeah, a mud patch. So bias are like systematic errors, right? Maybe in this case it's on a good note, right? But you can think of bias as a systematic error performed by a ML algorithm, right? So you can relate to this wherein, let's say you're cleaning your house, right? You do this regular cleaning, weekly you clean your house, but maybe yearly you do an in-depth cleaning, right? So maybe during any puja you do some in-depth cleaning by arranging your bureaus or sofas, right? But whenever you shift the place of sofa, you will figure out a pile of dust, right? So these are systematic errors we usually make, right? When we do this daily cleaning, we don't observe these dust pile of dust, but when we change the system, right? When we change one of the system, like adjusting the position of your bureau or a sofa, you figure out pile of dust, right? So that is what systematic error is all about. Here I'm considering a person who's sweeping has the agent or a model, right? And this agent has all these days, when he or she does this daily cleaning, it has forgot about cleaning the errors in this cleaning the dust in this position, right? Bureaus or sofas underneath. But someday you might discover this, right? So that's what systematic errors or bias is all about, right? In machine learning scenario, a high bias scenario is when the simple model, right? Be it a decision tree with a depth of 2, or a neural network with just single layer or a few hidden nodes, right? And these models tries to simplify any decision, right? Oversimplify, I think that's the right word, right? So any prediction it makes, right, this can lead to a high error rate, and this is this is a key indicator that your model is suffering from high bias. So the solution to mitigate bias is increasing the variance, right? So variance itself, high variance itself is a problem, but if you can mitigate a high bias model with some variance, you can get an optimal model, right? So on the other hand, let's see what high variance problem is, right? If you are going to train a model with a depth of, same decision tree model with a depth of 20, now you are increasing the complexity of the model, right? Now, this model can be so sensitive even to the errors, I mean, or outliers or noise in your data set, right? We don't want this kind of model also, right? So it fits everything in your training data. So problem with this kind of complex model is that it is not generalizable. Okay, so I've added some examples as well. Feel free to go through that. But you get it, right? So both high variance or high bias is not desirable at all. then what to do, right? So you see this black dot, right, a sweet spot added, right? So that is the most desirable place whenever you train a ML model, right? You try to find that spot, right? You try start with a simple model, try to fit your entire data set. If you're not able to fit it, try to increase the complexity of the model step by step, right? As soon you can reach a lowest loss with the most simplest model you can create, right? That looks like a best model to me, right? So you can use that as the sweet spot, and you can also train the model. Make sure with that simple model your loss should be lowest as possible, right? So this is what bias and variance is all about. uh, if you like this video, please put a thumbs up or subscribe it. And if you have any comments on any topics you are not comfortable with, let me know in the comment. I can cover that. Okay. Thank you.